We're going to be talking about using DNA matches, and this is my first part. We're talking about relationship accuracy. The primary purpose is to show you that the higher the shared centimorgans, the more likely ancestry is going to show them in the correct relationship grouping, and DNA is dispersed randomly. Some distant cousins won't show up in your matches at all. Okay, DNA is full of science, and we're going to kind of just move on to statistics and probability. You give 50% of your DNA to your children, and your spouse gives 50% of your DNA to your children, and it's a random 50%. And on average, two siblings are going to share 50% of their DNA with each other. Half comes from mom, half comes from dad. It's not quite accurate. If you have a half sibling, since you are only working with half of your DNA, the average shared amount is going to be 25% of your DNA. These are averages. Nobody is average. You can only pass on the DNA that you have. So the fact that your daughter has your mother's red hair doesn't mean that she's going to be a closer match to your mother than you are. You can only pass on the DNA that you have. And it's random. It's just random. So statistics are just that. They're statistics. They are not a hard and fast rule. Okay, we're going to look at third cousins. Everybody should know what a third cousin is by the time you've done any genealogy. So you got 50% of your DNA from your mother or father, one parent, and one of your grandparents may have contributed 25% to you, because you're going to keep dividing this by half. And these are averages of what you're going to get. So you're going to take your parent, divide by half. Since these are full siblings, you divide by half over here, divide by half. And by the time you get to third cousins, you share less than 1% of your DNA. Every step up and every step down, divide by half. Same thing for second cousins, twice removed. These are statistically the same as third cousins. You divide by half, 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 divide by half. But by the time you get over here, you're at 0.78%. Now, Ancestry is going to group your DNA matches as full siblings, first cousins, second cousins, third cousins, fourth cousins, and a special group down here called distant cousins. The higher the number of centimorgans, the more accurate the grouping is going to be. We already know that they're related, but how accurately Ancestry categorize them is up for grabs. We're going to look at fourth cousin, because that's where most of your cousins that you're going to be working with are. And every single DNA match will have a blue link to it, and you can see statistically what these mean. So for a fourth cousin with 43 centimorgans, 35% of these people are going to be third cousins. Second cousins twice removed. Half second cousins once removed. Statistically, these are all going to be the same group. 24% are third cousins once removed. 21% are second cousins once removed. 11% of this fourth to sixth cousin group are going to be actual fourth cousins and their equivalent. On the other hand, here's what the possibilities show on a first cousin. 94% accuracy. 94% of these people are going to have this two-step relationship. Four-step. 5% will have a different relationship. This is the probability. And then you notice that there's one missing percent, so somebody else can sneak in here. That's what those relationships show you. So the less DNA you share, the harder it is to predict the relationship. By third cousins, 10% of your relatives will not share enough DNA to show up as any kind of match to you at all. By fourth cousins, 50% of your relatives will not share enough DNA to show as a match. 50%, that's 1 out of 2. Half of them are not going to show. So what are you going to do about that? One solution is to test someone else in the family. That someone has to be higher or equal with you in the family DNA tree. You don't want to test your children. They are just diluted versions of your DNA. Or you can form an alliance with your DNA matches. That's what I've done in a lot of my people. I do this. And even siblings can have different matches. This is my third great-grandfather. I have 117 matches to him. My sister has 108. I see 17 for Uncle Francis. She sees 14. I see 31. She sees 33. I see 5. She sees 1. And now here, we're not into aunts and uncles, but actual great-grandfathers, second great-grandfathers. So these are my third cousins. And I have 8. My sister only has 7. We've already had a dropout at third cousins. These numbers indicate some difference. Actually, it's quite a big difference, because if I dropped open all of these matches, we only have 80 in common. The rest are different. And a huge family like this, it doesn't make a big difference. On one of our smaller lines, we don't have any of the same fourth cousins. Not a 1. When your family's shrinking, the best strategy is to cooperate with your matches to turn up more matches. We have done this to several of my relatives have combined together, and we've looked and got a big grouping of people that are our DNA matches, and we've created a spreadsheet. We know how many centimorgans they share, so that we can look at their trees and see what's going on. Because as you know, checking out siblings can turn up more evidence than a direct line itself. I mean, we are stumped, we cooperate, and we found things. And that's what I would recommend. That's the end of this lesson. I hope that means something to you, and we're ready to go on to the next lesson.